All right, let's talk about one of Python's most misunderstood players, the tuple. You've definitely seen it, and you've probably even used it without thinking much about it. But today, we're going to pull back the curtain and see why this simple data structure is actually one of Python's secret weapons.
So let's just get right to the heart of it. The one question everybody has. It looks just like a list, but you can't change it. You can't add to it. You can't remove from it. So seriously, why would anyone ever bother using it? That's the big puzzle we're going to solve.
And when you actually look at the code, it gets even weirder. A list has square brackets. A tuple has parentheses. That's pretty much it on the surface. But that tiny difference in punctuation hides a massive difference in how Python actually treats these things in memory.
To really get what a tuple is all about, you have to understand its one single, unbreakable rule. This rule is the key to everything. It explains its strengths, its weaknesses, and its whole reason for being. And that rule has a name: immutability. It's a really simple idea, but it has huge consequences. Once you create a tuple, it's set in stone. It cannot be changed. Think of it like a photograph. Once you take the picture, that moment is frozen. You can't go back and alter the photo itself. That's a tuple. And here is what that actually looks like in code. With a list, swapping out an element is easy, no problem at all. But you try that same move with a tuple, and Python just slams on the brakes. You get an error. And that's not a bug or a mistake. That's the whole point. Okay, so being rigid sounds like a bad thing, right? Like a total downside. But this exact feature has some really direct and measurable effects on performance. Let's see what really happens when you try to change a tuple. Which, of course, brings up a pretty obvious question. If they can't be changed, how come we sometimes see code that looks like it's adding something to a tuple? The answer is, well, it's kind of like a magic trick happening behind the scenes. So here's the secret. You are never actually adding to the original tuple. You can't. Instead, when you do an operation like this, Python is secretly building a whole new tuple from scratch. It has to copy every single item from the old one and then tack on your new element at the end. The original just gets thrown away. Yeah, and this whole copying business, it's not free. It has a real cost, and that cost is tied directly to the size of the tuple. In computer science, we call this O of n, or linear time. The n is just the number of items, so the more stuff in the tuple, the longer it takes. And this chart really drives that point home. See, adding to a tiny tuple with just 10 elements is nothing. But when you get to 100 or 1,000, that copy operation starts to get noticeably more expensive. The time it takes just keeps climbing in a straight line as the tuple gets bigger. And guess what? It is the exact same costly story if you want to remove an element. You're not actually deleting anything. Python is just building another brand new tuple, but this time it's only copying over the elements you wanted to keep. This is also a linear O of n operation. Okay, so at this point, it really sounds like tuples are just, well, slow and clunky whenever you need to make a change. But that's only looking at one side of the story. Now we get to flip the coin and see its hidden superpower.
I bet you're thinking exactly this right now. They seem super restrictive, and trying to change them is expensive, so it seems like a list is always the better choice, right? Well, not so fast.
And this is it. This is the tuple's superpower. O of 1, or constant time access. What this means is mind-blowing. Getting an item from a tuple takes the exact same amount of time, whether that tuple has 5 items or 5 million items. It is unbelievably fast. So how is that even possible? It all comes back to that one unbreakable rule: immutability. Because Python knows for a fact that a tuple size will never ever change, it can lay it out in a perfect, predictable block of memory. When you ask for an item, Python doesn't have to search for it. It just does a quick calculation and jumps straight to the right address. Instantly. So let's put it all together. Accessing an element by its index, that's our O of 1 superpower. It's instant. But trying to find a value where Python has to check each item, that's still O of n. And like we saw, anything that even looks like a change means making a full copy. So those are O of n too. You could really boil this all down to one simple idea. Tuples are fast to access, but slow to change. That's the trade-off, right there in a nutshell. So this brings us to the really practical question.
We get the theory, we see the performance numbers. Now, how do we choose the right tool for the job when we're actually writing code?
This breakdown really makes it crystal clear. Do you need a collection that's going to grow and shrink and change all the time? Use a list, no question. But if you have a fixed set of data, something like coordinates or RGB color values that shouldn't change, a tuple is the perfect fit. It's not just faster to access, it's also safer. It's like a guarantee that that data won't get accidentally changed somewhere else in your code. And that brings us right back to where we started. Why bother with a list you can't change? Well, now we know. You bother for that incredible performance when you need to read data. You bother for the safety of knowing your data is constant. And you bother for the sheer predictability that this immutability gives your program. So in the end, a tuple isn't a worse list at all. It's a specialized tool for a completely different job. And now that you know its secret, this fundamental trade-off between flexibility and performance, it kind of makes you wonder, right? What other performance secrets are hiding in plain sight in the code you use every day?